Okay, good day everyone. Welcome dito sa subject natin ng AC circuits or sa inyo, some students, circuit analysis too. Okay. So in this first presentation on basic AC theory, we'll be discussing some of the basics ng ng AC waveform and yung some measurements ng mga AC magnitudes. So later on, we'll be discussing sinusoids, no? And we'll try to represent or visualize ano ba yung mga AC waveforms nila, no? Uh, so siguro let's start na. Yan. So to start, meron tayo ditong dalawang figure or dalawang illustration of how AC waveform is formed and kung anong itsura niyan niyang waveform na yan, no? Um, when an alternator produces yung mga AC voltage, yung voltage na to, nagsuswitch siya polarity over time. So, dyan, makikita nyo sa figure. Of course, ganun din yung current natin. So, yung waveform na to, nag-change ng polarity over time in a particular manner. Okay? When we graph this waveform over time, no, sa time domain, yung tinatawag nating wave na traced by this voltage of alternating polarity from an alternator. So, ganito yung tsura niya. No? Ganyan, no? Sine wave ang tawag natin dyan. Okay? So, itong wave na to, yun yung nagre-represent ng ating AC voltage. Okay? So, sa ano naman, pag i-plot natin yung voltage from this alternator, medyo smooth yung kanyang change ng polarity. If we are going to graph itong ating voltage, so let's say 0 to 360, we can say na nakabuo tayo ng isang cycle, no? From 0 to degrees to 360, one cycle yan, one wave cycle. So every 360 degrees, yun yung pagro-rotate ng position and shafting ng isang alternator. So nabubuo niya itong ano na to. And from that, makakakuha tayo ng frequency, no? So if we have a period in seconds, let's say we have a period of 16 milliseconds base dito sa ano natin, sa illustration natin. Yung frequency ng ano na yan, na waveform na yan is equal to 62.5 hertz. That's when the period or yung isang cycle ng isang wave, ng sine wave is traced, no, ng 16 milliseconds. Yung kanyang frequency, which is the reciprocal ng period, is equal to 62.5 hertz. Okay? Yan. Pakita ko lang sa inyo na. So yun, no? Let's say, sinukat natin sa oscilloscope, ito yung ginagamit natin na device to check yung mga waveform natin in time domain. So kung isang period is measured at 16 milliseconds, yung kanyang frequency is 62.5 Hz kasi kinukuha lang natin yung reciprocal ng ating period. Ito yung formula natin for frequency, pakitandaan. Gamitin natin yan. Or palagi nyo gagamitin yan. No? Balikan natin yan. So, medyo popular naman 'to, 'di ba? Ah, 'Pag mineasure natin ng oscilloscope yung ano na yan, yung graph na yan. Since yung horizontal axis can mark the passage of time as well as the shaft position ng isang alternator, mame-measure na natin. O, the modern unit ng frequency is hertz. O, abbreviation yan is H, H, H and Z, hertz. Okay. So, which it represents the number of wave cycles completed during a second of a time. So, sa US tsaka dito sa Philippines, ang usual na ginagamit natin sa ano, sa ating mga power lines, no, is 60 hertz. Yung iba gumagamit ng 50 hertz. Okay, depende yan. Depende kung nasan ka. Sa Europe, most power system frequency gumagamit ng 50 hertz. So, ibig sabihin yan, the AC voltage only completes 50 cycle every second. Nakaka-repeat na siya ng isang cycle. So, yung mga radio stations, kung mapapansin nyo, di ba, yung kay, ano, IFM, 93.9 megahertz. Sige nyo. Or 101.9. Yan yung mga frequency. So, ito medyo matataas na to. Medyo million na yan. 100 million cycles per second. So, dati, bago pa naging hertz yung frequency na unit, ang unit ng frequency is cycles per second. Yun yung ginagamit. Uh, Although, iisa lang naman yan. Okay? Wala yung pinagkaiba sa Celsius tsaka yung dati centigrade kasi yung sukat nila. Ngayon, Celsius na siya. Okay? Um, yeah. We have this oscilloscope. Describe ko lang yung oscilloscope ha. Kasi para mas ma-familiar kayo. Meron tayo nito sa school. Kailangan meron tayo niyan. Kasi ginagamit natin yan to display yung mga changing voltage over time sa isang graphical screen. So for sure, nakapag-try na kayo niyan sa mga laboratories ninyo, no? When you are graphing or measuring some voltages over time. Ganyan din yung principle behind sa mga ECG tsaka mga nakikita nyo sa hospital. Oscilloscope din yan. No? Medyo special purpose lang for medical use. Okay? Anyway, itong mga general purpose na oscilloscope, they have the ability to display voltage from virtually any voltage source. Kahit ano pa yan, kaya niya. Yung relationship between period and frequency is very useful when displaying an AC voltage or current sa oscilloscope screen. By measuring the period of this wave sa isang oscilloscope, malalaman natin yung value ng frequency ng isang waveform, ng isang signal. Okay? So, ganyan siya. So, next slide is how is the concept of AC related to sound? Maganda rin to. How do I say it? Voltage and current, ano yan? By no means the only physical variable subject to variation over time. Diba? More common to our everyday experience is sound. Na wala namang pinakaiba sa alternating compression and decompression ng mga air molecules. So, yan yung naririnig natin or na ini-interpret ng tenga natin, yun yung compression tsaka decompression ng mga pressure waves sa air molecules. Dahil yung AC is a wave phenomenon, so medyo marami sa mga properties ng AC is katulad ng sa sounds. So, for this reason, sound provides an excellent analogy for relating AC concepts. Okay? For example, itong nakikita niyo dyan sa screens ninyo. In musical terms, frequency is actually equivalent yan sa pitch. Ito pala, nakasulat. No? Equivalent yan sa pitch. So, when we say low pitch notes, yun yung mga napoproduce ng tuba o kaya bass, So they consist of air molecules or vibrating air molecules na medyo mababa yung frequency o medyo mabagal. So low frequency. Pag sinabi naman nating high pitch, ito yung high pitch notes katulad ng nakikreate ng flute or ng mga katulad ng flute, no? Mas mabilis yung kanilang vibration. Yung air molecules mas nagbabibrate. So medyo high frequency yan. So may table tayo dito to represent yung mga notes, mga nota and their corresponding frequencies. Yan. So 200 pala yung A niyan, 220. Tapos may A sharp o kaya it is the same as B flat. Ganyan din yan. So hanggang C, we have 523.25. Okay? So yung difference sa piano, yung difference or yung agwat ng susunod na note na mas mataas is we call it 1 octave. Okay? So, yan. Dito makikita natin, the octave or 1 octave is equal to 7. Bilangin nyo natin. 1, 2, 3, 4, 5, 6, and 7. No? 7 white keys worth of distance sa isang piano keyboard. So, kung medyo familiar kayo sa Do, Re, Mi, Fa, Sol, La, Ti. Diba? Do, Re, Mi, Fa, Sol, La, Ti. So, 7 yan. Same pattern yan ng ating yun yung kumbaga 1 octave sa AC naman yun yung kanyang 1 cycle. Alright? So, analogy lang naman yan, guys. Meron tayo rito. So, other forms of alternating waves. What do we have here? So, while electromechanical alternators and many other physical phenomena naturally produces sine waves, this is not the only kind of alternating wave na nag-exist. Okay? Meron ding iba. So, other waveforms of AC are commonly produced within electronic circuitry. So, pwede tayong mag-produce na iba't ibang klase ng waveforms using electronics or electronic circuits. Okay, katulad ng sine wave. Okay? Square wave. Ganyan na itsura ng isang square wave. No? So, katulad ng sa sine wave, parang ganun din lang mo siya. Nag-iba lang yung kanilang itsura, no? Yung pinaka-waveform. Pero meron pa rin silang cycle or hertz. Depende, meron kasing mga square wave na ganyan, no? Okay. Then next we have the triangle wave. Okay. Yung mga example natin. And then we also have this what we call sawtooth wave. So medyo iba lang yan sa triangle, no? Kasi sa sawtooth, meron siyang vertical. Okay. Hindi katulad ng triangle. So base dun sa waveform, ganyan siya. Okay? Ano pa ba masasabi natin dito? Ang mga waveform na to, there are few that are common enough to have been given distinct names. So yan, ito yung mga yan, common. In circuits that are supposed to, manifest pure sine, square, triangle, sawtooth, voltage, or current waveforms, yung real life result is often distorted. Ibig sabihin, distorted. Meron siyang ganun dito. No? Medyo ganyan. Hindi talaga siya perfect. Pero square wave na yan. Okay? So, some waveforms are so complex that they defy classification as a particular type of waveform. Usually, ito yung mga waveforms associated with many kinds of musical instruments. So, generally speaking, so any wave shape bearing close resemblance to a perfect sine is termed sinusoidal. Napaka-importante ng term na sinusoidal para sa atin sa pag-aaral natin ng AC circuits. Okay? So anything different between labeled as they are labeled as non-sinusoidal. Being that the waveform of an AC voltage or current is crucial to its impact in a circuit. We need to be aware of the fact that AC waves come from or come in a variety of shapes. Right? So, ito na po. I-review lang natin bago tayo lumipat ha. So AC, napoproduce yan ng alternator, follows the shape of a sine wave. So we have one cycle of a wave is yung buong pag-ikot niya hanggang makabalik siya dun sa original point kung saan magre-repeat lang siya ulit. That's one cycle. And then the frequency is the reciprocal ng kanyang period. Diba? And then meron tayong iba't ibang klase ng waveform. Ng waveforms. Okay? Punta naman tayo dito sa measurement of AC magnitudes. Yan. So, meron tayo dito. So far, ang alam natin is that AC voltage alternates in polarity and AC current alternates in direction. We also know that AC can alternate in the variety of different ways. And by tracing this alternation over time, we can plot what is called a waveform. Alright? So, ang gandahan dito, we can measure the rate of alternation by measuring the time it takes for a waveform to evolve before it repeats itself. So, yun nga yung ating period. So, however, minsan we encounter a measurement problem if we try to express how large or small an AC quantity is. So, with DC kasi, medyo stable kasi yung ano, di ba? Yung current or yung voltage. Medyo ano lang siya, parang straight line lang siya pag DC, di ba? So let's say ganyan. Straight line siya pag DC. Hindi ko tulad ng AC, mayroon changes. Kaya minsan mahirap mag-measure, nagkakaroon tayo ng problema on expressing how much voltage or current we have in any part of a circuit. Di ba? So, paano nga ba na bibigyan ng measurement or single measurement of magnitude sa isang bagay that is constantly changing. Di ba? So, yan. Meron tayo iba't ibang klase. No? One way to express the intensity or magnitude, yung tinatawag nating amplitude. Amplitude ng isang AC quantity is to measure its peak height on a waveform graph. So, ang tawag na din natin doon, it is the peak, no, or the crest value ng isang AC waveform. Yan yung itsura niya. Yan ang nakikita niyo dyan. Yan yung tinatawag natin peak voltage of a waveform. Okay? So, ito, yan. Okay? So, yun yung ating peak. Meron din tayo, tinatawag nating peak-to-peak value of a waveform. Okay? Pag sinabi natin peak-to-peak, ito naman siya. Okay? So this is another way to measure yung total height naman between opposite peaks. This is known as peak-to-peak or PP, value of an AC waveform. So ito, magkabilang dulo, yan, tsaka ito. Yeah. Unfortunately, either one of these expressions, yung peak tsaka peak-to-peak, can be misleading when comparing two different types of wave. Diba? So, for example, yung square wave, let's say square wave, let's say 10, nagpipick siya sa 10. Okay? So, sample lang to. 10 volts. Tapos, syempre, mas mataas yung voltage or yung amount of voltage niya kumpara sa triangle. Kung kahit pa nagpipick siya ng 10 din, no? Bakit? Kasi kitang-kita naman sa figure that magte 10 volts yung square wave sa unahan pa lang, no? So, ganito karami yung lamang niya kumpara sa isang triangle wave. So, yeah. Okay? Kaya naman, medyo yung peak to peak, tsaka yung peak, medyo minsan misleading yan. No? Lalong-lalo na sa mga ibang square wave. Ano ba ang ibig sabihin niya pag ganyan? Pagka square wave, yung ating signal or wave, tapos ang difference niya is that, ano yan eh, it produces yung more load, no? Let's say meron tayong resistor, meron tayong circuit, tapos square wave yung input natin. Ganyan yan. Yan. So let's say LED to. Sample lang. Ganyan. So pag square wave, dahil ganyan yung kanyang waveform, no? Yan. Ang tendency is that the load will dissipate, magkukonsumo siya ng mas mataas na energy kumpara sa triangle. Okay? So, ganyan. Ganyan yung difference nila. Kumpara sa triangle, mas konti yung energy na nade-dissipate kasi nga, hindi naman siya, magkaiba sila na itsura, no? Okay? Kaya naman, there's another way. There's another way of expressing uh, the amplitude or the amplitude ng different wave shapes. Okay? So, another way of expressing the amplitude of a wave shape in a more equivalent fashion is to mathematically average the values of all points uh, sa isang wave. Okay? So, isa lang siya, average na lang siya. No? So, ang tawag natin doon, the average value of the waveform. Diba? So, kahit na mag-iba-iba yung average natin, uh, ano na siya, medyo representative na siya nung amplitude. Okay? Now, the problem with averaging yung isang sine wave, let's say, ito, tulad nito, the average for most waveforms is technically zero. Bakit? Kasi yung mga positive points, pag in-average mo yan, di ba? Magka-cancel lang yan dun sa mga negative. Negative. So, baliwala. Kaya naman, yan sabi dito, no? True average values of all points considering their signs is zero. So, minsan, yan din naman ang pangit sa pag-average ng amplitude. So, of course, this is true. Itong average na to, para sa mga waveform na merong equal portion ng positive tsaka negative. Pero kung yung ano, let's say ganito yung waveform, no? Ganyan. Medyo ano siya, hindi siya pantay. Ganyan. Ano ba yun? Ang pangit na sulit. Let's say dito sa positive, mas malaki dito sa negative. Yan. Ganyan. So, okay din tong ano, average value. Di ba? Kasi, mas malaki yung nasa ibabaw, tapos mas maliit yung nasa ilalim. Pero kung pantay kasi sila, yan, nag-zero talaga yan. Okay? So, however, uh, meron pa tayong ano, itong average is a practical measure, kumbaga, ng ano ng mga waveform. If we want to calculate the practical average value ng waveform consisting of all points on the positive axis. Diba? Parang ganito siya. Di ba kanina ganyan? So if we want to measure, yan, parang ganyan. So yung isa mo, invert mo dun sa kabila, ganyan yung itsura niya. Ito yung practical average of all points. Okay? So, so when the average value of a waveform is, kung ano yung pinag-uusapan natin dito, the practical average is intended unless otherwise. So another method of deriving an aggregate value is based on the waveform's ability to do useful work when applied to a load resistance. So unfortunately, mga measurement based on work performed by a waveform is not the same as the waveform's average value. Because the power na dinidissipate ng ating load is not directly proportional doon sa magnitude ng either voltage man yan o ng current. So rather, yung power is proportional to the square of the voltage or current na ina-apply natin sa resistance. So ano ibig sabihin yan? Ganito siya. Alam natin ang power is equal yan sa I squared R. Okay? And another one, power is equal to V squared over R. So, uh, pwede pa rin natin ma-measure yung ating tawag dito? Amplitude ng ating waveform by using this relationship. No? So meron tayong tinatawag na root mean square or RMS. Okay? RMS amplitude measurement is the best way to relate AC quantities to DC quantities or over other AC quantities. Kahit magkakaiba pa yan ng waveform shapes. So when dealing with measurements of electric power. So for other considerations, ang ginagamit natin dyan, peak or peak-to-peak measurements. Okay. Pero pag power ang pinag-uusapan, best gamitin is yung ating RMS values. Okay? So meron tayong circuits dito. We have the same amount of load resistance, yung 2 ohms. It dissipates the same amount of power. Di ba? 50 watts siya, 50 watts din dito sa kabila. So parehas lang siya. No? Pero ang pinagkaiban dito yung ating source. Sa unang circuit, we used a 10 volts RMS na AC. And dito naman sa pangalawa, we use a DC source of 10 volts. O, di ba? Because the AC voltage source na nakikita natin is equivalent to a 10 volts DC, we call this a 10 volt AC source. More specifically, we would denote its voltage value as being 10 volts RMS. O, di ba? Itong RMS na to, ibig sabihin is the root mean square. So, sometimes, the alternative terms, equivalent or DC equivalent are used instead of RMS. So, minsan, tinatawag natin yung 10 volt equivalent voltage or 10 volt DC equivalent voltage. But of course, mas maganda gamitin yung RMS. So, RMS amplitude is the best way nga pagka power measurements. So, for an instance, when determining the proper size of wire to conduct electric power from source to load, yung RMS current voltage or current measurement yung ginagamit natin, hindi yung peak to peak o hindi rin yung peak. Kasi ang principal concern natin dito sa case na to is yung current baka mag-overheat yung wire. Kaya naman ang function is or ang relevance nito is yung power dissipation caused by the current through the resistance of the wire. Okay? However, when rating insulators for service in high voltage AC applications, yung peak voltage ang most appropriate. Kasi ang principal concern naman natin dito sa mga insulator yung flashover na ano yan caused by yung saglit na spike ng voltage irrespective of time. Okay? So, ganun lang siya. Discuss lang natin to ha. Amplitude. Ano ba yung amplitude na yan? Okay? So, the amplitude is the crest factor of an AC waveform, for instance. Yung crest factor is the ratio of its peak value divided by its RMS value. Then, meron naman, tinatawag tayong form factor ng isang AC waveform. It is the ratio of the RMS value divided by its average value. And then, para sa mga square wave na waveforms, yung crest and form factors equal to 1. Kasi yung peak is the same as the RMS and the average values. So, ayan. So, puputulin muna natin dito yung ating discussion and let's continue na lang on the next part. Okay?